All right, here we go. Last page on the 4.1 notes, and it says piecewise functions, graph the piecewise functions. And the nice thing about piecewise functions is that your domain is given to you. Domain is given to you right here. Here are the x values that we can plug in. And if we kind of went through those, let's start at negative infinity and kind of follow our way up and see if we have any exclusions. And so anything less than 0 is a negative, and it can be plugged in. And but the first one says not including 0. However, our next piece of the piecewise function says 0 is included, so no exclusions yet. Continuing on to include 3. And then the last one is x is greater than 3. So there's no numbers that are excluded. So let's go ahead and quickly just get our domain. Before we even graph it, we can see our domain is all real numbers. And we should kind of validate that once we get our graph going, but we'll see that that is in fact true. And so let's go and graph these three pieces, and I'll graph it in a couple of different colors just to try to make that more clear. So this first one we'll graph in blue, x plus 2. When x is less than 0, we graph x plus 2. And so if it's 0, we're going to have 2. If it's negative 1 plus 2 is 1. And really it's a y equals x plus 2. And there's our slope of 1 up until, and actually should have a open circle. Sorry about that. This needs to be an open circle right here at 2, because at 2 we're not plugging in, when x is 0, we're not plugging that in. So it's all these points up until they're not including 2. Now, from 0 to 3, when we plug in 1, we plug in 2, and when we plug in 3, our output is 3. So you can think of this as y equals 3. So that starts right at 0. So 1, 2, 3. This is a closed circle here, going until we hit 3. And again, a closed circle here because 0 and 3 are both included on that graph. And then the last portion is going to be, we'll do here in this green color, and it's x squared minus 4. And so if I plug in 3 is going to be where it starts, that x value, and if I plug in 3, I get 3 squared is 9, 9 minus 4 is 5, open circle there at 5, and then it's kind of a, that's going to be the vertex of our parabola, and it, that's not the vertex, I kind of am misspeaking there, but the parabola would continue on out. Really, the vertex would be over here, but that's not part of the piecewise function. So that shape of what would be the continuum parabola heading on up will be the rest of our function. So again, there's all the real x values that I can plug in. I get a different piece of the graph, but there's always an x value I can plug in. There's always going to be an output for me. Now, what is my range? Well, my range is really specific on this one. For the first piece of the function, and so actually I'll write this out in the colors as well to see if that helps out. Our range is going to be any number that is less than 2. I can plug in all y values less than 2, or all g of x values. That might be a better way to write that, but I'll leave it as y for right now. Now, I never have an output between 2 and 3. So y is 3 as well. And then I never have anything between 3 and 5. Those are not included. And so my last one's going to be y is greater than 5. Notice there are some outputs that we never have. I never have an output between 2 and 3, and I never have an output between 3 and 5. We've got some gaps in our ranges, and so that's why we've got to write it this way to kind of clarify those pieces. All right, B. So this one says that we've got h of x at these various points, starting at -2. And -2, here's my lowest number, but -2 to +2. +2 is included up to 5, and 5 is included onto positive infinity. So my domain, the lowest domain value I can plug in is -2. And x is always greater than -2. There's no values. X can never be less than -2 for my range. or sorry, my domain. Now let's go ahead and graph it. And I'll graph them in each color again. So from -2 to 2, I'm graphing negative x squared, which is going to look like this here. So open circle, because 2 is not, or -2 is not included. Parabola here. And again, 2 is not included. So another open circle. That's the first piece of the graph. Now the second piece of the graph is that from 2 to 5, including those values, our output is -4. So -4 starts up, and so it actually fills in my circle, so it's going to be continuous still at that point. It goes on to 5 and is again a full circle. It's included because it, oh no, sorry, that one is not included. This one is an open circle because it's not or equal here. So open circle. And then get the green one again. Is going to be -x plus 1 from 5. So if I plug in 5 here, -5, it would be my -5 plus 1, which is at -4. And so right there, it actually ends up being continuous again. Since there's not a jump in the graph, I could draw that whole, the graph with my pencil never kind of coming up. So it's going to be continuous. We'll talk more about that at a later time. So what are my ranges? My range here is, well, I can head to -infinity. That's not a problem. But the highest y value I ever have is 0 right there. So y is less than or equal to 0. All right, and last one. Good job hanging in there. We've got our parabola, or sorry, not parabola, but our absolute value graph with a vertex at 2, 3. So 2, 3, graph that. And on the left side, oh, actually, is this one not given to you in piecewise function? No, you can change it. We've learned how to change this into a piecewise function. Right now, I'm just going to go ahead and graph our graph. On the left of -2, when x is, or the left of 2, when x is less than 2, we have -2 slope, or +2 slope. Then once we get up to an x value of 2, now we have a -2 slope. All right, so our domain is all real numbers again. There's no x value I can't plug in. However, my range is going to be, the highest y value I ever have is 3. So y is less than or equal to 3. And if you're confused about changing this into a piecewise function, go back to, I believe that was the 3-6 notes, something around there. And we go through an example of how to split this up into a piecewise function. All right, hope that helped.